and which part that you need to emphasize when you study and practice or exercise. Okay, maybe start with chapter 10. Okay, chapter 10. So chapter 10, we learn first is about parametric, and second is polar. This is mainly our two distinct sections. The parametric one, I hope you still remember, okay, at least finding slope, arc length, right? Even area. I have area. Okay. And then the emphasis for the calculation will be more on polar. More on polar. It can be arc length. It can be the area. Especially finding the area and then having some polar curve. I hope still remember. Try to do some exercise on the polar curve, okay, the area. And then still in chapter 10, we have the conic section also, right? Conic sections. At least for this conic sections, this is just the basic that you need to have. Differentiate between the conics, right? There are type of conics, right? And chapter 10 and 11, there will be more on chapter 11. So chapter 10 probably only 35%, 35 to 40%. The rest will be chapter 11. Because I think chapter 11 has a way lot of content, and chapter 10 just a limited content. Okay. So let me just focus on chapter 11. Okay, chapter 11. Chapter 11. First, we learn about sequence. Right, sequence. And then from the sequence, we know that the sequence can be converges, right? Or diverges. And how to take this converge and diverge, we are going to use the limit, right? We are to use limit. And then based on the definitions, okay, we need to have monotonic, right? Monotonic sequence, bounded, and we know that this will be converged. And then we learn on the series. But it can be 1 or 0, depends on, maybe it's easier for 1. Now the series, we also learn when the series is converged and when the series is diverged, right? And you need to distinguish, I hope you can distinguish between the series and the sequence. The sequence is just an order. Okay. When the series is you are adding plus. Okay. But the sequence itself, we can represent the sequence inside the series, right? So we have a sequence, and we add all the sequence that becoming a series. And also you also need to remember that to make this or to prove this, we need to have the definition on partial sum. Okay. We need to have partial sum, and then we can have a limit. And through some set of methods that we discussed, like several methods we have, like from divergence test to ratio test, root test. Then we can how to determine. So here, how to determine. Always start with divergence test. I will just take some several methods that I think quite important. The ratio test. This is geo or P series. And then the other one that is important is alternate series. And the alternate series, it can have implications on whether it's called absolute convergent, conditional convergent, or just a divergent. I hope you still remember what this is. 3. Okay, and then from the ratio test, if you remember the ratio test, we can have 3 implications to make it converged, diverged, or inconclusive. Okay. Less than 1, greater than 1, I hope you remember. And then from ratio test, from those conclusions or from the conclusion that is converged, we can rewrite the series in terms of new variable, which we include x, and we call that power series. Okay. So from ratio test, we can develop in way more, we call this power series. It starts from the x to the power of n, right? We can have 1 plus x squared plus x cubed plus ... And we can imagine this in terms of 1 over 1 minus x. This is the first representation function that we learned. The power series is 10.8, and then this is 11.8, and this is 11.9 representation function. And when we represent, we are doing it based on this 1 over 1 minus x, and then we can reform the formula and forcing it to become 1 over 1 minus x. And then still, we look on power series. Remember also, because you will have n and x, right? You have n, which is you are going to limit the n to find the convergences, but you also have x, in which the x is actually not really exactly. So for example, the converged diverged at the beginning, if it's converged, you know exactly the number. Okay, it's converged to 5, it's converged to 4, 2, 3. But in power series, the converge is getting some interval, which we call the interval of x. We call that the interval of convergence, okay? The interval of convergence. So we have the radius of convergence and interval of convergence. This is R or I. Okay. The radius means you have some set interval. You're going from some set of A to plus some value and minus some value. This one is called the radius. Okay, you have some certain interval. The half of it is the radius. Okay, that's the idea. Okay, so remember this. Okay, how to find the radius, how to find the interval. Okay, at least to find radius and interval, the first step you need to do in power series is always using the ratio test, because this is the implication of the ratio test actually. So if we have set of series that's having some set of x, okay, aside from n, which means that it has some set of interval that you need to figure out. You need to find which interval is converged, okay, which one is diverged. Okay. Okay, so 11.8, 11.9, and then 11.10. Okay. 11.10. 11.10 is actually an advancement or a modification of power series. Okay. So generally, you can write this. Let's say it's x minus a. Okay. Let's say you can write like this. Okay. So in 11.10, actually, this is how to expand this form, and we call it Taylor and Maclaurin. Taylor and Maclaurin. The idea of Taylor and Maclaurin is basically the same. Taylor is with A. Okay. This is at point A. Or Maclaurin is at point 0. Or at x equals 0 is x equal A. And then after several definitions, we know that the coefficient is, let me write with different color. It's related to this f with derivative n. So the function derived several times and n factorial. Perhaps to understand more clearly on how this Taylor-Maclaurin will be written, maybe you can try. So before you start doing the exercise for practice on Taylor and Maclaurin, maybe the first thing you can do is you take some functions, maybe the easy one like sine x or cos x or maybe e to the x, and then try to develop your, maybe start this Maclaurin because it's easy, it's going to be at 0. So try to make it on your, in your paper. You try from the first derivative, second derivative, third derivative, and then you put all the functions, the result, and its coefficient inside the expansion. So try develop some essential function. Okay. Okay, perhaps let me just give you several questions. Okay? But this is more or less what I'm going to emphasize in your midterm exam. So first, you can bring your calculator. Okay, so I allow calculator to be used in the midterm. So you can prepare. If you don't have, you can maybe borrow it to your friend or maybe buy the calculator. Yeah, I think that's the important one. Okay, let's see what we have. Let me start with some set of questions. Okay, let me see. Use Maclaurin series. Or maybe find representation of series from function. Let's start with the easy one. Okay, as you can observe from these two questions, if you want to represent functions to a series, it's better to use some set of functions that are essential in the Maclaurin series. Like for example, the first one, this has sine. The second one having the ln 1 plus something. So you can think essential functions, what they are looks like, and try to modify the series from the look of this function. Okay. So if you see here, you can relate the first one to the sine x, right? It's not too complicated. You just take the inside and then change the x. Okay. The second one, you having the ln, and of course, I think still have the essentials for the functions in the Maclaurin, which is ln 1 plus x. First changing the x with x cubed, and then after that multiply the x squared, okay, for the series. Okay. Now the problem is sometimes you are not really sure the functions, okay, or how to take the functions into its power series form and how to make it come true. Well, although it takes time, I think you can just try to confirm it like from the scratch. I think it just takes some 5 minutes to write down all the essential things. For example, sine, we can start with writing down the Maclaurin. So let me write here. It's a general Maclaurin. So we start with just a function with x 0, and then we start with the first one, and then we start with the second one, and then you can add more and more n, 3, 4, 5. Okay. Okay. So what we are looking for is we start from sine. So sine x at x equals 0. Okay. So first write down f of x, sine x, f0 is just 0. So we start looking for the functions and its coefficient. Okay. So this is also the same. We are looking for the functions and its coefficient. So the second one is the derivative. The first derivative, this is cos x, and f prime of 0 is 1. And the second derivative, you get negative sine, and it's also 0. Third derivative, it's becoming negative cos x, which is going to be negative 1. Okay. Now from this pattern, you will see that every time it's the n is from if you take this is 0, 1, 2, 3, when it's 0, 2, maybe 4, 6, and the even number, all of the coefficient will be 0. Okay. So for sine, we are just concentrating on find which one is the odd one. Okay. Now we can write down the formulations for the Maclaurin series as, so we can write down this as x. Okay, we start from x, which the coefficient is 1. Okay. The second one is 0, so we skip this, and then we have another one which is the third one, and it's negative. Okay. So we will have a negative, and then x cubed, and then 3 factorial. Let me just write 1 factorial so you will see the pattern here. And then negative, 0, 1, 0, negative, 0, and then you can write down the pattern. So we will have the positive 5, and then negative 7, and let me just write dot 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 like that. So we develop the sine x, okay? We develop sine x. Now we can rewrite this in terms of the series, if you would like to write. And then since we need to have it's positive and it's alternate signs, we can write this as negative 1, start from 0, and then we can write the x is an odd number, so we start from 2n plus 1 and 2n plus 1 factorial, okay? And if you know sine, then you will get cosine easily from here, and you just derive this. So minus 1, minus 1. Okay. Okay, now if you know this sine, okay, so this is sine x. Then sine pi over 4x is equal, we exchange the x with pi over 4x. So let me write, this is pi over 4 x, and then 2n plus 1, and then 2n plus 1 factorial. Now it's up to you if you want to make it more convincing, like maybe 4 going down here, and the up, the top equation is pi x and then 2n plus 1. That's up to you. But I think if you just write this, because you have limited time on your exam, I think it's just okay. For me, it's okay. Unless maybe if they have options, then you need to pick options that is equivalent with the answer. Okay, now the next question is the second one here. The f of x is x squared ln 1 plus x cubed. Now first we can start from the ln 1 plus x. Okay. Now if you don't know how, you can start practicing the how to develop the Maclaurin from scratch. But it takes time, 5 to 7 minutes at least. But if you write maybe faster, maybe you can write it really fast. But if you know and some of the essential functions, you can just write down what it is. Okay, so you can write down this is equal to and I start substituting some relevant variable. And then if we have x squared, then we will have x squared like this. or maybe just directly write plus 2 on the x like this. Okay. Okay. Okay, let me go through next question. Still related to the ln and Maclaurin. So if I have f of x, ln, and 1 plus x, and 1 minus x, okay. I think I mentioned this in your test, right? In your test, the online test. So the first 3 non-zero terms of Maclaurin of f of x are okay. Now, if we want to solve this, if we look back to what we have in ln 1 plus x, this is what we have. Okay. We can rewrite this, or maybe let me copy this. because it's asking 3 non-zero terms of Maclaurin, and we know that we need to check the all the n actually. So probably it's better if we are taking from n equals 0. So let's rewrite this in terms of from n equals 0. So we just added and the ln, if we have because ln, we can rewrite this as minus, right? And basically, if we have minus, let's just take the n equals 0 and exchange the x. Exchange the x. And simply it's become n plus 1 and then negative 1. Because we have negative from the x and coming outside. So f of x is ln 1 plus x minus ln 1 minus x. Since it's negative, it's become plus, right? It's become plus. So we will have and then you can check from 0, 1, 2. So check 0, it's become 2. 0, 0, it's become x. So 2x. So this will be 2x. Okay. Check for n equal 1. For n, let me write here. For n equal 1, 3, 5, 7, it's becoming 0, right? So we are just skip 1, so take 3. We take 2, sorry, we take 2. It's become x cubed. Will be 2 over 3 x cubed. And then similarly, we will have x5. So this will be the three non-zero terms. Well, it's actually still have n equal 3. Well, no need to write all, just 3 non-zero things, okay. Okay, maybe last question. Last question. Interval of convergence for the series. And this morning I upload another video for practicing, so I will also attach to the Moodle later. It's still practice. So I hope within this additional videos and our practice today, it can help you guide which one or which one that is more emphasized or maybe more will be more having more discussion in our midterm. And to help you out with some technical calculations, please prepare calculators. Solve this as usual. The power series need to reflect on ratio test to check on how good the convergence is. How about the radius? What about the interval you will get from the ratio test? Okay. The ratio test start by taking the ratio on an plus 1 and an. And this we can write first. We let an is equal to x with power of n and n. Okay. So take the absolute value to remove our alternate signs. So we can have an plus 1. And also, whenever you find any series that has a power like this, it's an obvious to use the ratio test. So obviously, ratio test will be your priority. Whenever you find, for example, 1 like n squared n, blah 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 with some complexity here, the best way to take this, any guess? Any guess if you have like 1 over n squared of n plus maybe sine n, any complexity here, what method you're suggesting? The most logical method, that easiest to use. Yes, comparison. So you can have either direct comparison or limit comparison test. I think you're good to go. I think to be safe, just use limit comparison. I think for most cases, if something is happen, then you can compare it to some theories that is easy to determine, and then you can compare between those two. Okay. Or if not, comparison, not you check divergence, not easy. you can check geometric P series, or if not, the one way to solve probably using the telescoping sum. Especially if this series having some, maybe having the form like this, you can make it something minus something. It's probably a hint to use telescoping sum. Telescoping sum. Okay. Okay, now let me just finish this, and this will be having x, having 3. So you will have, and you need to have less 1 to be converged, right? To be converges. So it should be, okay, x should be on this, but need to check, okay? Check. Okay. So this is our interval probably here, but we need to make sure whether we need to include both or maybe we need to remove some of them. Okay, so we need to check -3, put on the series, and you need to determine the series, whether it's converged or diverged. Okay, I hope you can practice. Okay. And also I will make some, probably some short notes for guiding you for midterm exam. Okay. I think that is for today. So we will see you at the midterm next Tuesday. So maybe you can also remind your friend if they forget to come. Okay, now I do apologize for the session. Okay, it's not well recorded because something technical error happening in my device. So let's start with the just reviewing what we need to emphasize on chapter 10 and 11. So let's first start with chapter 10. So chapter 10, what I would like to emphasize is we go directly to 10.2, which is the parametric one. At least you need to understand how to get the dy dx, the tangent, the area at least, okay, and the arc length. So there will be questions, some of the questions that is related to all of this, maybe 1 or 2, not all this 3, but maybe 1 or 2, okay, or maybe combinations. And the next one is the polar, 10.4, calculating polar, in which there are several emphasize. Okay, the first is to find the area of polar curve. We are referencing on the sector. Okay, so we are having the integrations of the sector, and then this is through the d theta, and r is function of theta, right? Okay, and also length. Okay, length, like this polar curve, how to measure the length. Okay, it's similar to what we have in parametric, but the difference is we are going to exchange this into r and the r over d theta. Okay, now still in chapter 10, we also have the conic sections. Okay, I will ask you to provide the identification of which conics of several of some listed equations. So you need to identify whether it's hyperbola, parabola, or ellipse. Okay. Now the chapter 11, we start by looking at the sequence, and by doing that we are having directly conclude whether it's converge or diverge. We have a set of numbers, and if we are looking at the patterns, and the patterns, they are going to have one finite number, we say that we converge to that number. Or we can say that if we are using the limit, we can use this limit approach to get to our L, which is converge. Or at the end of the day, we can say that
every sequence that has a monotonic property, or it's increasing or decreasing, and it's bounded to a number, then it will be a converged sequence. So if you see sequence like we have, like it's getting decreasing like this, and it's going to approach maybe this is 0, and then this will be bounded to 0, or the limit equaling to 0 or L, or any number. Like maybe if we have like there, and maybe this is L, okay, this is also bounded, and it's increasing, it's bounded. Okay, and then we move on to the series. So the series, we are having, this is actually a sequence, but sequence, when you add all of them, it becomes a series. Okay? And to understand the series, we are going to have the partial sum. The partial sum is how we can refrain or restricted the value so that we can evaluate and approximate the conclusions, or the final conclusion of the series, whether it's converged or diverged. And the one way that we can do at the beginning is we can take the limit of the sequence, and if it's going to have some number, which means this sequence will take some numbers, and when they add off all the number, then it will be unlimited, right? So which means that the sequence L, this we can describe as L plus L plus L plus L, which means it has many L, which means it's diverged, and we cannot really say that it's converged to any number in series. Okay, and also if we take a limit and it's not equal to 0, we can say generally it's diverged, or if it is infinity, it's also diverged. But what happens if we have this limit equal to 0? It's not conclusive. It's not conclusive, as I mentioned in the lecture, and you can review your notes why this is not conclusive. Okay. And from here, we are going to have some methods to check whether the series is converged or diverged. We have divergence test, p-series, geometric comparison, ratio or root test. Okay, and from all of this, we take the emphasis on ratio test, in which we have a new way to set our series, which we call the power series. The power series begins with this x with power of n, in which we can also rewrite this in terms of functions. Okay. But in general, what power series means is this. We have x, we have n. Okay. We have x in which that we have this interval of the convergence. So the convergence is not equally to one number, but it can be some interval. Okay, and we have two terms to describe, that is the radius and the interval. Okay, so we will have to analyze the convergences through through some method, and the method that we are going to use the power series is the ratio test. I think it was obvious because most of power series will deal with x, n, or maybe something variable x with n, okay, and is in the power, and that means if you want to check whether it's converged or diverged, the best way to analyze is through the ratio test, right? Okay, for any power that has the n, the integer n. Okay, and then from there we are going to move to Taylor-Maclaurin, in which this is actually an expansion of our power series. So our power series can be described in a more general way that we are writing here. This is the Taylor series. Okay, this is actually, we can describe in way more a lot of terms here. Okay, and when we are having x equals 0, that will be our Maclaurin series. Okay, Now we have the questions. Determine the series diverge or converge. We have this one, the first one. It's easy to see. It's alternating, and then we can prove that this denominator, because if we are take n equal 1, n equal 2, n equal 3, you see that it will be decreasing in terms of the value. And the limit itself is equal 0. And based on alternate series, I didn't mention in previous page, this will converge. Okay. And the second one, whenever you see any complications like this, you see any complications in the denominator, you will be guided to the direct comparison test or limit comparison test. But we can maybe just take the limit comparison test to make it more concise and consistent, and to make sure that you get what you want. Okay, and we get that this is a positive number, which is if this is converged, the reference converged, then this is converged. Okay. If this is diverged, then this is also diverged. Okay, if you get this is positive number. Okay, now this next one is this power series. Okay, so power series, you see that it has x and this has a power of n. Okay, can have many variations. It depends on the questions. But if it is asking interval convergence, which means first try to prove the ratio test, try to check whether it has some convergences in several intervals. Okay, and after we get our ratio test, we know that our radius should be less 1/3, which means that our interval is between -1/3 and 1/3. Check one by one. Okay, and then we then conclude that because this 2x will converge, both of them are converged, then our interval need to include both of negative, positive 1/3. Okay, you can rewind and pause the video to observe how the answer. Okay, or maybe to take notes. Okay, and the next one is the ln. If we want to make this representation functions, which means we need to relate this to our original function, which is 1/1 minus x. If we derived ln, we get -1 minus x, right? Which means that this is the negative of our original power series. Okay. Now, if we integrate back to this ln, then actually what we are looking for is the integration of this. And we have this integration. Now, if we want to take some proof and check when x equals 0 to get that the c is actually 0, then we will have the ln 1 minus x is this. Okay, we can also change the k to k equals 0 to n equal 1 with this k plus 1 equal n. This is just to make sure that we are on the same page, and you need to be careful when you are reading the questions and look on which one is your integer. Okay. Okay. The next question that probably we will have is a sum of the series. Okay. So we will have this series, in which this is an obvious series that you need to relate this to the one that you are having in your reference. So this is a reference, right? Your reference. So if you are not really sure how to build the formula or how to stack the formula, then you can start from the scratch. For example, from sine x, or maybe if you want to from cos x is also the same. And you need to write down all, and then take the x at 0, and then you start writing the long equation of the Maclaurin, and then you can make make out the formula, and from the sine we can derive, and it's becoming cosine, and this is what we have. Okay. And through this series, we can rewrite the form. Now we can take this pi and 6 inside this power to n, and then we see that this is actually just cos pi over 6. Okay, and I think it's the answer. Now the other way, or the other questions that we have, is kind of having more complex. Now if we look on how we are dealing with, if we see that we have this 2n plus 1 factorial, we are probably getting the vibes that this is probably 2n plus 1 factorial is our sine. And if we take this 4, so 4 squared is 4 and 4, and then we can take this, or we can take this 4 and then 4 and plus 1. Now this n plus 1 or 2n plus 1, we can take this to the to up here and combine with pi over 4, and then we can have 4 in the denominator here and pi over 4 here. Okay, and then looking on what we have here, this is actually our series, and we can check when n equals 0, what will happen, and we will have we can change to n equal 1 to make it into our sine in Maclaurin, and we have sine pi over 4. We need to multiply with negative 1 over 4. This is when n is 0, right? When n is 0. Yeah. Because when n is 0, this will be negative. Okay? And this is what we have. Okay. Now the last questions we have is to recreate this integral arctangent t over t dt. Okay. So we need to make the series in terms of Maclaurin. So first we deal with the tangent inverse. This is what we have. Okay. And the same thing if you are going to deal with the tangent. So we can start with something like from f of x, and then f prime x, and then you need to derive this. I'm not sure how to derive that, but probably it will be squared, and then you have some quotient rule here, and then you can take all, and then you need to put x equals 0, and you can rewrite all the terms, but it will be this formula. Okay. Now the tangent inverse will start with divide by x, okay, because it has this divide by t. So divide by x, so divide by x mean that this will be gone, minus 1, so we will have done, we are not having any so it's removing 1 here, and then we are going to integrate. So this is using fundamental theorem of calculus. So what we are doing here is we are integrating this. So we are going to plus 1 and then multiply this with 2n plus 1, and this is the answer. Okay. I hope this can help you to learn and study. And my suggestions for the Maclaurin, you can know some of the patterns, but if not, then well, my suggestion is to remember it. But if you don't have time to memorize, then you need to write from the scratch, and I think you need at least 5 to 10 minutes if you want to write most of the questions or most of the reference. Okay. Now I think that's the summary for some practice for chapter 11. Okay.